The only thing we've actually talked about is the first four up here, haven't we? The rest we'll get to at some point. Way on the end is paranasal sinuses, nasal cavity. Yeah, and we'll look at those later. Films of the skull we'll do next week. And then this is a venous drainage of the brain, the dural sinuses. So, you know, after going through the arterial system, goes to the capillaries and comes back out to the surface. The surface veins, you see, that ultimately drain into a series of sinuses that lead to the internal jugular vein. Okay, so we'll study those next week. But one thing to point out is that where these surface veins join what's called the superior sagittal sinus here, that's a site where you can get tears, especially in the elderly. You shake your head around, you may get a little tear there, a slight bleed, and you get a very slow developing subdural hematoma.
Shaken infant syndrome or something?
Well, infants are pretty tough on that, but it's more in the elderly. These surface veins have a tendency to bleed, and you get, you know, after a couple of weeks, Grandpa falls down because he's got a head full of blood, right? He doesn't know it. Okay, so let's talk about the real stuff, the angiograms. The coronal views are easy to recognize from the lateral because you can see both eyes and you can see the nasal cavity, right? And over here you can see the nasal cavity and the roof of the mouth, so you can tell which is coronal, which is lateral. Now, some people have trouble with that, believe it or not. Okay. Notice the following, that some parts of the head appear to empty, like this part and this part, because they're supplied by other arteries and the arteries that are perfused. But what it shows you isn't there's very little collateral circulation, right? In this patient, assuming these arteries are all intact, the blood pressure is probably equal, so there's no mixing from the right to left or back, front to back in those through the circle of Willis. Okay. Now, if you do have a plug in one of those, maybe some blood would go over to that side to the communicating, or maybe a little bit of blood might go back, but it's not nearly enough to supply. So that's the trouble with the brain. We have end arteries, they're just like the surface arteries in the heart. They're end arteries, and not a great design. Well, what are we looking at? This is since only one half the head is filling, then we look at the internal carotid system. Okay? Because coronally, if you see both sides filling, you know that's vertebral basal. Okay, so here's the carotid system. This is the internal carotid coming up. And right there is the beginning of the carotid canal, where it enters the skull, comes forward medially, and then up out of that canal into the middle cranial fossa. And here we're kind of looking forward. You don't see it, but there's an S loop in here. There's a little S there. That's called the carotid siphon. Okay, and that then ends by dividing into the middle cerebral, which does the lateral surface of the hemisphere, and the anterior cerebral, which does the anterior surface, okay? Our medial surface of the hemisphere. Now, a little bit harder to see on a lateral view, but one thing that's really easily recognizable is the anterior cerebral, because it sweeps over the corpus callosum that divides the two halves of the brain. So this artery here is very easy to pick out, you see. So that's the anterior cerebral artery. And the rest of this is the middle cerebral, okay, that you're looking through. So anterior cerebral, middle cerebral. This, by the way, is not inside. This is the ophthalmic artery. So it's not a branch of the circle of Willis. It's one of the last branches, one of the only branches of the internal carotid artery. Now, you know about the homunculus, a somatotopic map on the brain with respect to motor and sensory areas. This is the hips up here, your trunk and upper limbs and head and neck are right like that, okay? And then thighs, knees, legs, and toes like that on the medial surface, okay? So if we were to block this artery right there, see? So let's call that the left middle cerebral artery. You would lose motor and sensory function on the right upper half of the body. Okay? And if you block this artery, you lose motor and sensory on the right lower half of the body. Okay? And it would be just the opposite for over here. vertebral basilar system. Both basilar arteries come up the neck through the transverse processes, get to C1, they go over the top of C1 into the foramen magnum and join on the brainstem as the basilar artery, and the basilar artery travels up the pons and ends by dividing into the two posterior cerebral arteries. And that's on this view and on that view. Okay. Now this cerebral artery, posterior cerebral supply the visual cortex. Right? Remember they're wired up based on the visual field. And so if we block the left posterior cerebral, we would get what?
Vision loss in half of both eyes on
Which half?
the left. Right.
All right, you're correct. The right half of the visual field of each eye would be lost. That'd be a right homonymous hemianopsia. You hemianopsia on the right, lose right half of your visual field homonymously in both eyes. Okay? It's called either hemianopsia or it's also called hemianopia. Just to make you confused. But it's not blindness.
I really think we should play Balderdash with anatomy.
Balderdash. How do you play that? You get to punch somebody if you make a wrong answer? Where do you come from anyway? Texas? No. Where in Illinois?
DeKalb.
Oh, that's right. You told me that, I think. Just north. Peoria is just north of that.
Yeah?
Oh. Let's see. I remember you. No. Balderdash. Huh? So there you go. You got that kind of possibility lesion, that kind of a lesion possibility, that kind of a lesion possibility. That's all we can talk about because we don't know much more. And then the other thing is this artery is a superior cerebellar, and you can find a nerve right in there between those two arteries. Posterior cerebral, superior cerebellar is the nerve coming right out, which is which nerve is it?
Number 3.
Yes. Oh.
See, it's been 10 minutes.
Third nerve, yes.
Okay, now